So we need to find out the average velocity of something that's traveling at a rate of t squared minus 2t. So average, we're going to use that f of b minus f of a over b minus a formula, that same slope formula. Now, it'd be nice to see what's happening here. So I took the equation, set it to 0, found out where it crosses the x-axis. So it crosses at 0 and it crosses at 2, and I know this is a parabola that opens up. So it looks something like that. It's a pretty poor drawing, but okay. Now, when t equals 0 and t equals 2 are the 2 points that we're concerned with. So if I want to think about what's going on here, this line right here is kind of like what the slope we're finding of, and that is a slope of 0. So the average velocity we know is going to be 0. Now if we go back and do the algebra for this, we're going to do f of b, so f of 2, or s of 2, equals 2 squared, right? 2 squared minus 2 times 2, which is 0. 4 minus 4 is 0. And if we do f of 0, if you substitute 0 in here and you substitute 0 in there, it's also going to be 0. So if you think about the average slope, f of b is 0 minus f of a is 0 over a change of 2 minus 0, which is 2. We're going to get an average thing of 0, a slope of a rate of 0 feet per second. That's because it's, well, if you get into physics, it's moving backwards. So it's starting at a place, moving backwards, turning around, and coming back. So that's why it's an average slope of 0. So now let's do this next slide with the instantaneous velocity. So to find the instantaneous rate of change at t equals 2, what we're doing is, because we can't find a slope of a single point or how fast something will go in at an instant in time, we're going to approximate it by doing some limit magic with it. And what we're doing is we're trying to let that point line up so it's going on there. So we're letting that triangle, or the rise and the run, so that the run goes to 0 and the rise goes to 0. So there's no difference over that from that point and what this other point. So the points line right up. So what we're going to do is come back and we're going to use that same instantaneous rate formula, and we're going to use this equation, the t squared minus 2t, and every place we see a t, we got to, for this first part here, every place we see a t, we got to substitute in 2 plus h. So I'm going to write the limit as h approaches 0. I'm going to write that once, and then I'm just going to write what we're substituting in. Here's the t squared minus the 2 times 2 plus h. So that's just this first part. That's just this first part of the formula, right? That's what this whole part's about. So now we're going to put a subtraction sign in here and do the second part. So subtract, and then we're going to replace 2 with t with 2. And if we think back to that work we just did, we know that that was equal to 0, right? Because 0 squared minus 2 times 0 is 0. So that's nice. That doesn't come into play at all. I'm going to put that over h. Now we're going to FOIL that, expand this all out. So we're going to FOIL that first one. Notice I'm not bothering to write the limit. I'm just going to know that it's there. So 4 plus 4h plus h squared minus 4 minus 2h. That's what that whole top becomes if I expand that out and distribute that through. Then minus 0 I'm not going to worry about. That's over h. Now let's cancel off some stuff. Well, that 4 and that negative 4 is gone. 2h and 4h and negative 2h are like terms. We're going to put those together. So I've got 2h plus h squared all over h. And then if I tried substituting in 0 right now for h, I'd still get an indeterminate form, 0 over 0. So I'm going to try to factor out an h here. So I'm going to factor in h out, and if I can squeeze this in over h, and now I can cancel nicely without breaking any algebraic rules. And then, so now I'm going to do this last step, and if I had room, I'd write it down below. So I'm going to write the limit as h approaches 0 of this last step, and all I'm left with is the 2 plus h. So now, when h approaches 0, that becomes 2 plus 0, so my instantaneous rate of change at t equals 2 for this equation is 2 feet per second. Okay, a little more complicated because of the squaring, but it's the same as we've been seeing.